Okay, good afternoon, everybody. It's about 2:05 and we'll get this thing rolling. The idea here today is to introduce the Stratasys F123 Series printers. It's a very big release, and Stratasys and Javelin Technologies are very excited about these machines. And today what we're going to be doing, we'll be going through the printers top down and looking at the overall specs, and then diving deeper into the tolerances and speeds and feeds, and then going into the software that drives the printers towards the end of today's session. My goal is to have this session around 45 minutes and then have 15 minutes afterwards for either frequently asked questions or Q&A, depending on what we get out of this webinar. So as you can see, there's a couple new things going on with the F123 series printers, but let's gloss over that for now and we'll jump into it later on. So for those who are not familiar with Javelin, here we are. We are a nationwide company here in Canada. So we have offices across the country, starting in Oakville, that is our head office, but we also have one in Dartmouth, Nova Scotia, and man, are they getting hammered today with snow. I hope everyone's doing okay over there. And then Winnipeg, Calgary, Edmonton, and Vancouver. Our printers are located in the Oakville, Calgary, and Vancouver offices, and the idea is to have them on display for customers to come in and check them out and see how they work and run and operate, and also get little tips and tricks in our open houses. So if you're ever close by, feel free to give us a call and pop in. We'll be more than happy to show you around the gear. It's pretty impressive stuff. So Javelin Technologies is a solutions-based company, and what we are is we focus on the product lifecycle. What does that mean? Well, Javelin focuses on the people, technology, process, and manufacturing. Let's start at people. We train our individuals as well as our customers as well as possible. So our training portfolio is extensive, and Javelin started in SOLIDWORKS about 17, 18 years ago and has diversified since then. However, the training aspect of SOLIDWORKS is a huge part of our portfolio and what we offer as a service. So we enjoy and we specialize in training the people at your company. From there, we have the technology to implement that information to get the process going. So we resell SOLIDWORKS, PDM software, as well as Stratasys printers. From there, we have processes to evaluate what your company is doing internally, how they're designing, how they're bringing products to manufacturing, and we can give you full documentation on it, which is very, very helpful, and we do all sorts of on-site assessments. Then from there, with the help of 3D printing and additive manufacturing, we can support your manufacturing structure. So we can either take you from prototype to R&D to development to manufacturing back into prototype to complete that circle. So we have products and services all throughout your portfolios. We want to make sure that we're there to help no matter what. So who am I and what am I doing? My name is David Hayes, and I am a 3D printing application engineer here at Javelin Technologies. I've been here for about 2 years now, and I focus on the pre-sales application and post-sales service. Now, what does that mean? Well, on the pre-sales side, my role is to go in with the sales team and strategically advise on which 3D printers work best for which customers, but also which applications do not work for 3D printing. And it's very important to understand the difference. The reason is, people always want to 3D print everything, and it's not always cost effective to do so. So my job here is to strategically advise customers on the best applications to use 3D printing and to gain traction internally so that there are more and more applications and 3D printing becomes more viable internally. After the sales cycle is finished with any type of customer, I also go in and install, maintain, and support the printers myself. I'm fully certified on the machines, so I can tear them apart, roll my sleeves up, and get those elbows dirty if I have to. And what I find is actually helps me on the pre-sales role, because I can tear down the machines and rebuild them. I better understand how they're printing, and it gives me a better comprehension of why the parts come out of the printers the way they do. So I find that both sides of the sales cycle helps. And then my areas of specialty are medical, automotive, architectural, and manufacturing applications. I know it seems a little bit diverse and spread out. However, that seems to be where we have found lots of traction in the last couple of years within 3D printing, and I've gravitated towards those. So within medical, we can take patient-specific MRI scans and turn them into 3D printable file formats and get the person's surgery and print that surgery 5 or 10 times ahead of the surgery. So a surgeon can go in and practice ahead of time. In automotive, what we're doing is we're taking our biggest, baddest machines and we're printing out huge fixtures, go, no-go gauges, and also nests. So if a part comes off an assembly line, somebody can quickly take that part off the assembly line, put it into our 3D printed gauge and fixture, and it will either say, yeah, it's within tolerance, or no, it's not. And it's far cheaper and far faster to print these fixtures on the shop floor than it is to make them conventionally. Architecture, well, I personally live in Toronto, which is very close to Oakville, and the condo market is incredibly hot right now. It's burning up. So what we're finding is architecture is a large product for us. So what we do is we will go in and help the architects design their files and print them in 3 dimensions so they can get better ideas of spatial awareness, shadows, and floor plan layouts of cities. And then from there, I specialize also in manufacturing applications, whether that's injection molding, go-no-go gauges, shop floor tooling, or whatnot, whether it's aerospace, automotive, or consumer products. I kind of work all throughout different sectors, but those are my specialties. And then my background is in mechanical engineering, and then I was an early GrabCAD adopter, so we'll get to that in a minute. But first, let's talk about the machines. So the agenda for today, the idea is to introduce the F123 machines. And when I say F123, it's actually I'm referring to 3 machines, and it's the F170, the F270, and the F370. Now they've just compiled them all into one, just to make it short and concise, but when I mention the F123, I'm talking about all 3 machines. So I'll go over the portfolio of the 3 machines and show out the differences. From there, I will talk about the production specs to show you how each machine is different within the F123 range. And then I'll talk about the accuracy and tolerances. It's important to understand what your machine is capable of doing ahead of time. And what's nice is we found some very good data on exactly what the printers can print at any given time. And then we'll talk about the materials. What can these machines print? What can they not print? Because that's very important to understand before considering buying a printer. And then the speed. Speed is a little bit of an abstract thought, but what we've done is we've compiled some information from prints, and we have given quantifiable numbers to the speeds of the printers compared to other printers on the market currently. Then towards the end of the presentation today, I'm going to show you guys a GrabCAD print demo. Now why that's so important is GrabCAD Print is the software that now drives all of the printers on Stratasys portfolio. Now what it's doing is it is currently any machine being developed will be developed for GrabCAD, and any machine that is currently on the market will either be grandfathered in or has already been so. So we'll get to that later on today. The idea behind GrabCAD is to eliminate STL files, and so you can take native CAD files, take them directly to print, and then the reports. It's a very important feature for optimized management of 3D printing. It gives you total visibility on what your machines are printing and when. So let's dive into it. The F170, 270, and 370 will look very similar from the outside. These are the 3 machines, and the idea is these machines are the most effective prototyping for all levels of users to get high quality parts printed right the first time. Long way of saying we want to make sure you get exactly what you want printed with no errors every single time that you go to print. So what you're going to commonly see throughout this presentation is the fact that these machines are extremely reliable, extremely tough and robust, and they're fast. So the industry has demanded faster printers, and the industry has demanded less expensive materials, and the industry has also demanded bigger bill envelopes. So Stratasys has delivered. What they're trying to do is they're trying to give bigger sizes with faster build speeds, as well as different materials and ease of use, all from a reliable printer, and that's exactly what these machines are. These machines are a very big step forward to the current portfolio. We'll talk about which machines they're replacing in a minute. So as you can see at the bottom there, these machines not only support the ABS and ASA, which is conventional for Stratasys materials, but it also now supports PLA options, which we'll get to soon. So here is a breakdown of each printer and what it can do. So the Stratasys F170, if you think about the Dimension 1200, that is what's comparable to this machine. This machine's print envelope is 10 inches by 10 inches by 10 inches, so a good introduction size. What we commonly see is here they talk about schools and professionals seeking to generate low-cost concept models and parts. What we find is this F170 is a fantastic starting point. If you want to get your feet wet with 3D printing, you want very hands-off printers, and you want something that's reliable, this is a good printer to get in-house as a trial run before jumping up into the Fortis 450 and the Fortis 900 down the road. And the idea is the entry point for cost is low, and you can get into this machine and print inexpensive parts to show your company the feasibility of 3D printing internally. So the F170 covers ABS, PLA, and ASA. It is driven by GrabCAD print, which we'll get to later. It has 4 slice heights with the same print head, and it has 2 material bays. So that means 1 model and 1 support material option. Now the F270 has 2 times the material capacity and a larger tray than the F170. So if you look at the size differences as XYZ, so it's 12 inches by 10 by 12. What that equates to is about 44% bigger than the F170, and it also supports ABS, PLA, and ASA. It's driven by GrabCAD print, but what you'll see here is it has 4 material bays, and what that means is you can have 2 bays for support material and 2 bays for model. Now the 2 bays for model have to be the same model type. You can't put in an ASA and an ABS. You will have to have the same type. What it's doing is it's effectively giving you a larger build capacity if you wanted to print something over the weekend. As we go into the Stratasys F370, a little bit of the bigger brother, it has the highest capability and largest build size. So as you can see here, the size is 14 inches by 10 by 14. So not only is it 36% bigger than the F270, but you can also print PC ABS. What does that stand for? It stands for polycarbonate with an ABS blend. Why is that important? Well, for our automotive people out there, they want very firm but very stable fixtures. So the polycarbonate material gives you that very stiff and very stable dimensionally fixtures to align go, no-go gauges, for example. But what they've done is PC is inherently brittle, so Stratasys has blended in ABS into the PC blend to allow that if you drop the fixture, it won't crack or chip or fracture. So the idea is to have the shop tools as a PC ABS blend to be more robust and resilient. So if you were to drop it by accident, nothing would happen. So same thing as you can see here, it's driven by GrabCAD print. It has 4 slice heights, 4 material bays, has auto material changeover, which means that if you have one spool that empties and you have another one lined up during a build that's over the weekend, it will automatically change over, whereas previously you would have had to hit change the material yourself manually. It is also driven by Insight if you would like. Now the difference between GrabCAD print and Insight is very much the same as an introduction software and a experienced user software. Insight has been around the industry for quite a while now. And what it does, Insight gives you the capabilities to program exactly where you put material, how much you put, and what kind of patterns you would like to put in there. So if you wanted half of your part to be solid and half to be honeycombed, but not all at the same level, you could do that with Insight, whereas you cannot do that with GrabCAD. GrabCAD you can strictly only hit, I want to be fully honeycombed throughout this part, or I want this part to be completely solid. You cannot select different features and have them in different infill patterns. It's the biggest difference between Insight and PCAV, or in GrabCAD. I apologize. We do at Javelin offer a Insight training course, so for all those customers who might be interested in the Fortis or the F370, we do provide a very, very good in-depth 2-day training course on Insight, which will take you from not knowing how to use Insight to be an experienced user and almost an expert by the end of day 2. So the idea behind these new machines is that they are turnkey solutions. What you get with your printer or your F170, 270, or 370 is you get reliable hardware. So as you can see the printer there, it is built in the United States of America. It has upgraded hardware. It's got extremely strong motors and bearings. The things are workhorses. So the idea is for reliability and repeatability every single time. You also get material options. You get various materials on the same printer, and that allows you to go from something like a PLA, which would be great for a draft or a first prototype, to an ASA, which is a great idea for a functional prototype that you might want to look a little bit stronger and have stronger features, and then take that same part and put it into a PCABS for the end-use part to be a little bit stronger, a little bit resilient. And then you also have your soluble support tank. So when the printer prints a part and it comes off the tray, you actually have 2 materials attached to the part. You have the model material and the support material. Now the support material is water soluble. It comes in that wash tank, and what you do is you put your part in the wash tank, hit go, come back an hour later, and it should be clean. Now what you also get is you also get a mobile monitoring app. So GrabCAD Print is now via mobile app, and it's supported for, I believe it's both Apple's and Android. And then you have GrabCAD Print itself on your workstation to drive the printers. And then for the F370, you also have the Insight software, which again allows you to have more customizability in your parts. So let's talk about the F123s. This is across the range of the printers. So we highlight the 370 here, but what you'll see here is a 45 dimensional accuracy parts printed on 3 different Stratasys F370 printers, and there's your tolerances. So 99.9% of the parts had accuracy within 0.01 inches plus minus. So fantastic tolerances, very tight. It won't be the same you get on a machine or a lathe. However, for 3D printing terms, that's very strong, those numbers. And the official printer spec for the F123 are going to be produced within an accuracy of plus minus 0.2 of a millimeter or plus minus of 0.002 millimeter. It just depends on a millimeter on top of a millimeter, whichever is greater. So we can talk more about that offline, but that's a very, very strong tolerance that these printers can achieve. Now, I gotta say, size matters here, so don't be limited by size. All of these machines have been chunked into their price points to fit strategically within the Stratasys portfolio. The F170 is a fantastic starting point if you want something that's a little bit bigger than a U-print. And then the F270, the idea is if you're a little bit more comfortable and you want a little bit more throughput, you can jump into the F270 that gives the same features, so bigger build volume. And then the F370 is going to be more of your production workhorse, and you can take parts from prototyping to end-use manufacturing components. What you see here at the bottom are the slice heights of each of these printers. So the F1, 2s, and 3s can all achieve 5 thou, 7 thou, 10 thou, and 13 thou layer heights with the same print head. There's no more swapping print heads out. So in our previous machines, let's take the F270. So the F270 will replace what's called the Fortis 250. And the Fortis 250, you used to have to change out the tip if you wanted different slice heights. Actually, I apologize, that's the 370. So before, you would have to change the tip out on the F370 to get different slice heights, whereas now you don't. It's one print head with one tip, and it's self-correcting for the calibration. I apologize. So the calibration itself is no longer user-driven, it's all automated. And what would happen in the previous machines is you would have to change out the tips for different slice heights, and then you'd have to sit there and spend about 30 minutes calibrating the tip to make sure that it's properly secured on the print head. Whereas now, it's a very large, chunky print head that slides in, slides out. It's got some great clips, very user-friendly. I just got back from SOLIDWORKS World where we were messing around with one of these machines. You can change out a print head within 1 minute and it's ready to go. All you do is you back out the material, take out the print head, put in a new one, throw the material back in, and you're good to go. It's very hands-off, and what it's doing is it's eliminating user error in prints, which is fantastic. So what you can see here, the 370 is 96% bigger than the 170. So what we commonly see in the field is a customer will jump into a 170 as a starting point. They want to test out 3D printing, but they want parts that are going to be reliable, tough, and robust with some customizability on what you can get with the fill patterns. They'll probably print with the F170 between 6 months and a year, and what they'll find is the machines work so well for their needs, they'll probably upgrade. So when they upgrade, they'll usually jump into a 370 or a 270 depending on their demands and their throughput. But what they'll do is they'll keep the 170. And the reason is the 170, as well as all the other machines, can print in PLA, which is a very economical material. Jump into that next slide. But when you keep the PLA on the 170, you can put the PCABS on the 370 and have a workhorse. So you could have production components coming off your 370 while your engineers are prototyping with the 170. So what we find is a lot of our customers will have simultaneous machines going all at the same time. It's kind of the idea. You have redundancy. So here are the supported materials. So in the 170, you get PLA, ABS, and ASA. Now what does that mean? Well, PLA is an organic compound that simulates plastic. It feels very much like a plastic, and it's actually corn-based, so it's relatively inexpensive and it's most economical. ABS is your ABS that you would get in any Lego block. It's a generic plastic, but it's strong. It's very strong for what it is, and I think it gets overlooked for its strength. So I think ABS is a very important material to keep your eye on. Then ASA is a dialect of ABS. It's essentially the same material, except for that ASA has UV stability. So if you're going to have parts that are in the field outside, ASA is fantastic. It also has a little bit of a more matte finish, so it's easier on the eyes if you don't want layer lines in your parts. So the F170 and 270 support PLA, ABS, and ASA, whereas the F370, you also get PC-ABS for those automotive fixtures and those just a little bit tougher materials you need for those applications that you're looking for. So just a run through of which machine gives you which material and which color as well. As you can see there, we have two types of canisters in these machines. We have 60 cubic inches and 90 cubic inches. So the idea is you can have both. Most customers we find buy 90 cubic inches, but you know, if it's a university or school and cost is an issue, then 60 cubic inches are available and they're a fantastic option. What you'll see is in PC-ABS you only have white and black, and the idea is you don't need colors on the shop floor unless it's red, but you can always go ahead and paint the parts afterwards. So very important to understand here. And I actually did a cost analysis today on one of the parts that one of our customers is going with. And a part that cost $42 in ABS costs about $15 in PLA. So it's about a third the cost of PLA as it is ABS. That's kind of your ratio. So if PLA costs $10, your ABS part will cost about $30 to kind of give you a good ballpark. So let's talk about some speed. So here are some stats. The F123 Series using PLA in draft mode, and what draft mode is, it's a crude way to print for quick prototypes. So it's your thickest layer height as well as your least amount of infill, but the infills will not fail. So it's guaranteed to be strong, robust parts, but it's just optimized for speed. And what you see here is you have 2.7 times faster than a MakerBot Z18, which is pretty impressive. Then you've got 3.7 times faster than a MakerBot Gen 5. You have 3.5 times faster than a Zortex, and you have 4.9 times faster than Raise 3D. So what you're seeing here is these machines are significantly faster than the ones they are replacing, but they're also significantly faster than what's readily available online. Because people are saying that, you know, MakerBots are fast, and why can't Stratasys printers be as fast as MakerBots? Well, now they are. Now they're faster, and they're not only faster by a factor of 0.5%, but they're a factor of 2.5 times. So it's pretty impressive stuff. So GrabCAD Print. Let's talk about the software that drives these printers. So let's move over Catalyst. GrabCAD is here to stay. So the idea behind GrabCAD is to replace the Catalyst print server. And what it does is Catalyst will take your files. So if you design your file in SOLIDWORKS, you would conventionally have to save it as an STL. Your STL file would then be imported into Catalyst, and Catalyst would drive your machine. Now here, the difference is GrabCAD replaces Catalyst in the sense that you can take a file from SOLIDWORKS and save it as a solid part or any SOLIDWORKS file you may wish, and then GrabCAD can read that file and take it to the printers directly. So what it's doing, it's eliminating STLs. I'll get to more on that in the next slide. But if you desire, Catalyst can still be used on current machines. However, it cannot be used on the F123 printers. Only GrabCAD can be used on F123 printers. So going forward, all machines will be developed for GrabCAD print. Personally, after using GrabCAD for quite a while now, it is a fantastic software, and there really is no reason to stick with Catalyst. The visibility you get from GrabCAD and the functionality and the ease of use from GrabCAD is not even close to be rivaled by Catalyst. The current version is 1.3, so if you already have GrabCAD and you want to check, the current version 1.3 is a big jump forward again. There's been a couple of significant steps recently. But what it does, it supports the F123 printers, which is fantastic. So as you can see, which printers are supported by GrabCAD? It's going to be your F170, 270, and 370s, your Uprint, your Dimensions, your Fortis Series, and then your PolyJet J750 in beta. The idea is that GrabCAD can also read VRML files for your J750, and you can put textures and colors to the part very easily. So we're really only talking about F123s today, but if you have questions about J750, I'd be more than happy to answer them, and my email will be on the last slide. So GrabCAD eliminates the needs for STLs, which is fantastic. In my daily process, I would say 80% of my headaches are due to STL files or faulty STL files, and they are the bane of my existence. So what GrabCAD has done is it can import native CAD files directly as well as STLs. So you can bring both, whichever you wish, and then using native CAD files avoids the possible STL errors. What an STL file is, for those who don't know, if you have a cup on your desk and you model that in SOLIDWORKS, design it in SOLIDWORKS, and you create it into 3 dimensions. For a printer to print that cup, you would need to save it out as an STL, which is as simple as file save as STL. But for those people who are not as lucky to work with SOLIDWORKS, and they might work with another CAD software called maybe Inventor, Google SketchUp, or what have you, the mates and joints in those softwares are not nearly as good, and they're not knitted as well. So what happens when you save an STL, the printer can't read the STL file correctly because it wasn't generated correctly. So there might be errors, there might be gaps, there might be holes, there might be missing triangles, who knows. So SOLIDWORKS, generally speaking, creates good STL files, and when it creates STL files, it creates triangles all over the surface of the part. Now, the reason it triangulates all the surface is the printers need to know where the surface of the part is to determine where to put material and where not to put material. Now our GrabCAD has jumped in. It has eliminated the STL file and has gone straight to printing. So it can read your native CAD file, and then it can tell the printer where material should go and where it shouldn't go based on the CAD file, which is a huge step forward, because without that approximation that an STL file does, you get much more accurate builds every single time. So you have no more faceted surfaces or stepped surfaces. It's always going to be true and smooth. So you can also import assemblies from SOLIDWORKS. So GrabCAD can just bring in assemblies, and what you can do is you can highlight, I want this part assembled, or I want this part separate. Totally up to you, and it works quite well. From there, you have fewer files in your database, and it reduces the amount of STLs. So what commonly happened before is if you had a file for customer X might have 16 SOLIDWORKS files, but that would also mean that customer X would also have 16 STL files. Whereas now there's no more STLs, so it doesn't clutter up your file formats. For your improved workflow, on the left you see the conventional 3D printing workflow. You have multiple CAD designers having to go through one operator who would drive Catalyst, and then the Catalyst operator would send the parts to the printer. Now the issue is that would be a bottleneck, and if that person goes away on vacation or is sick, it would slow down the 3D printing process, and it would be a bit of a headache. However, with GrabCAD, because it's cloud-based, anyone in the world who has access to your login information, so anybody from any team from Canada, United States, India, wherever, could log in and can print on your machine, provided they have access. So it's a very safe and secure way to put the machines on the cloud. Now you still need an operator to go ahead and hit the print button on the machine. However, what it allows people to do is if you had to work on a file and set it up and start queues while you're on the road, or maybe you're jumping on a flight, you could set up queues, hit the queues to say go, 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 and then whenever that person might be into the office while you're on your flight, they can all go ahead and print those files while you're away. So it's very easy, and it removes that print operator bottleneck. So I'm sorry, there's a typo at the top there, but it should be GrabCAD version 1.3. And reports. Reports are live, so you can monitor material consumption, printing demands, and job history right from your browser. Not only that, you have an improved rotation tool, and then VRML files for J750 are supported as well. But let's focus on reports, because this is where the meat and potatoes are for GrabCAD. So what reports are, they're cloud-based, so when you log in with your login information on grabcadprint.com, you then get access to your machines that are online. So you can access your machines and what they're printing from anywhere in the world. And what it looks like is it looks like this. So you gain greater visibility. So managers who have printers at a shop, maybe they have multiple locations across the country as we do, we will run all of our machines from GrabCAD, and then all the data gets uploaded through secure encrypted code to the cloud, and that information is then kept. So anybody can go in who has access to your GrabCAD account can then dissect, okay, in the month of March, we're about to print 16,000 cubic inches because last year we did the same. So you have predictive analytics, but you can also see which machines are printing, when their demands are, which materials they're printing, and which machines are printing which materials at what time of the year. So what you can do is you can not only be predictive in your idea of how to stock your material consumption, but you can also take a look and say, you know what, this machine's not getting fully utilized. We can take some of the work from machine B and put it to machine A. As you can see from the graph on the right there, not only does it show you consumption by hours, but you can do it by material consumption or whatnot. So it gives managers and company owners very good visibility on what is happening on their machines, where previously this really wasn't readily available. You could get, job information on how much a part would cost and how much it would take and consume, but it was simply a spreadsheet and it wasn't very easy to look at, whereas these graphs are very easy on the eyes and they're very easy to manipulate. So again, reports gives you full visibility on the printer's job history. So this is what you would traditionally see in Catalyst, and it's still available in the report section. And what it shows here is your job, the owner of the job, when it started, when it completed, the duration, the status, and then it shows you what materials you used, how much of which material you used, and as well as the support. So it's an easy way to dissect, okay, we might have a little bit of discrepancy between the materials that we used last month. Let's check it out. Oh, yep, there's one unaccounted job for there. That's fine. So here we've got supported file formats. So you can take a look through the list, but that's what's in version 1.3. I know, again, 1.2 is listed, but 1.3 just came out recently. So what you have is you have STL, you have solid parts and solid assemblies, and then you can go through the rest of them from there. So what you'll see here is not only can it import SOLIDWORKS files natively, but you can also do CATIA, STEP, IGES, OBJs, Unigraphics, Solid Edges, ProE, Parasolids, and VRMLs. It's very impressive, and GrabCAD is very robust. Not only that, they have a team of engineers and software developers constantly working on which file formats they can import. What I'll do here, I'm going to shift gears and I'm going to bring up GrabCAD Print to show you the power of it. So this is GrabCAD Print. So what we have here, let's go ahead and hide this. So we've got our build envelope for F370. What you see here, your X is along the back of the tray there with the tab. Your Y comes from the back of the machine towards you, and then your Z is up through the cube. Now what I've done is I've previously loaded a file that I've worked on, and what I'm working on right now is I'm working on an iPhone case, which is a Motorola cell phone from the 1980s. I'm sure some of you will notice that. So it's very easy. You have the conventional tools here, so if I want to rotate my part, I can either manually rotate it by degrees, or I can select face to sit on there, and I'll say I want that to be the bottom face. There we are. Now what you'll notice, the biggest difference when you're looking at this is, why is there this tower here? So this tower is not wasted material compared to the old machines. What happened is the old machines, like a Fortis 250, used to purge every once in a while during the print to clean out the tip. But it wasted time, because every time I had to purge, it had to stop, move away from the part, go to the purge area, purge over that purge area, and then I had to wipe the tip, come back and continue printing. Whereas what the new F123 printers do is they will print a sacrificial tower here, which does not consume any more material than your old machines. The material consumption is identical. It's just much faster, because no longer does the printer have to go from here back to the purge unit and back. It can just simply print, go to the sacrificial tower, purge by printing out this substructure, and then continue on printing. So now that my part fits in the tray, I can go ahead and select the features for my part. So my part, I can go ahead here and I can either arrange it, or I can choose the infill settings. So here, my support structure, my infill patterns, my slice heights, my material, my support material, and my build part style. So I can choose draft, which should automatically change. So here's the following things that were changed when I changed it from normal to draft, so support style and part fill style. So what you'll notice is if I go from normal to solid, and if I go to draft, what you'll see here is it automatically changes sparse low density, and the support style will be sparse as well to reduce the amount of material and time it prints. So let's go ahead and change that back to solid. So our part's now solid. Here are 4 layer heights that we can choose from, 5, 7, 10, and 13 thou. And then our part material. So I'm working with the F370, as you can see at the bottom here. So I have PLA, ABS, ASA, and PC ABS. So if I choose PLA, what's interesting about PLA is it will not build the support structure and it will not build support material. So what happens when you're actually using the machines is if you change to PLA for a quick draft that's cheap and easy but might not be as consistent, you actually take out the support print head altogether and you put in a fan assembly to keep the part cool. It's very important to keep the part cool when you're printing with PLA. So if I go ahead and estimate this, it's solid, 10,000 layer height, PLA, support materials also PLA, because remember you only have one print head in. I have removed the support print head. If I go ahead and estimate this, what it will do, it's going to be slicing the file. Oh, we have a failed estimation. Perfect. Of course it didn't work. That's okay. So what we'll do is we'll skip over that for now. But if I go ahead and take the PLA and let's put ASA, let's see if that works. No. So for some reason, it's not working today, but that's okay. It's not the end of the world. What I was going to show you is, let's see if we can slice. Let's try a different file. This part will take a little while to import. There we are. So what you're seeing here on the right hand side, let's get rid of this feature. Here is showing that models have errors. This is one of the strongest parts of GrabCAD in the user interface. So let's see where those errors are in these models. These were generated by STLs, and what you're seeing here is you're actually seeing your STL error. So based on the color coordination here, we know that it's open faces. So that means there's probably a hole in the part. So if we go ahead and click open faces, you can see there's an issue right in that area. So let's go ahead and say repair all models. What it will do is it will approximate that surface based on the geometry of the surrounding area, and we'll fill it. So we've gone ahead and fixed that part. That part is ready to build. From here, let's go ahead and let's select this guy. Let's set the settings. So smart. Let's do solid, ABS. Great. Let's see if this will work. Here we are. So that might take some time. Again, bear with me. Computer's a little bit slow. But what it's essentially doing currently is it is taking each part and it is slicing it in that layer height. I've assigned 10,000 layer heights and it's slicing it individually. And then when it's done, it will allocate where the support material needs to be, where the model material needs to be. And not only that, but you can show you a graphical representation of where it is. So while that's loading, what I want to do here is show our job queue. And what you see here is we have a Fortis 250 that's online. We've got a 450 and the SC Plus Uprint. So that's what we currently have in the house that's online. Our other printers are offline right now. But what I could do is I could go ahead, once this part finishes, I could go ahead and send it to the Fortis 250 and hit print. That will then get added to this job queue. And after the job queue is done, then I can add another build after that if I wish. So if we can time it, we could schedule a delayed print, start it at 6 p.m. or 5 p.m. So it will build all the way till 8 a.m. Come in, take the parts off the printers, put them in the wash tank, and hit go on the next one because I would have already queued up the next job. So I can do that for any one of these machines here if I wanted. And what it does, it gives a lot of power for managers to manage the job queue because you can start to push around jobs depending on their priorities and their importance. So we'll just wait for this part to finish. We're almost there. And then to get to the reports from GrabCAD Print, what you would do is you would actually continue building from here. So when you're ready to print and you've seen your estimations, you would hit print. It'll go to the machine. You go to the machine, you hit start. And on the F123s, there's brand new interfaces which are very easy to use, which don't require any calibration, so it helps a lot. You'd pop into a new build tray, which are quite a bit more flexible on the new machines, which help you remove parts afterwards. So you go ahead and start a print. And then if you wanted to see your reports, you'd actually go to the GrabCAD website, which is where all the cloud-based solutions are, and you could then go and access your reports from there. We're almost finished. Again, just want to reiterate, this is not a software issue with the speed, it's a computer issue. I think this computer's a little bit down on RAM. And so what you're seeing being built here, the green is going to be your model material of where the part actually is, and this golden brown or different color here, that's actually going to be your support material that gets washed away afterwards. Okay, here we are. So what you can see here is, there we go. So we're at a bird's eye view, and what we can do is we can drag this through the layers so you can see how the part's going to be built. Zoom in a little bit. So this area here is going to be your support material on each layer. The lighter green area is going to be your part that's actually being built layer by layer. And to give you better visibility, what you can do is you can actually, instead of seeing all layers, you can say I want up to layer, for this layer would be 298, which just essentially clips the part at where you're zooming in and zooming out. So that's as the part builds, you can see where the model material is, where the support material is, and you can also check the thin walls to see if they're going to fail or be useful. You can do a whole bunch of different ideas here. You can do all layers. You can do a single layer at a time to see if you have any problematic areas. You can zoom right in and you see how the material is going to be built, the way it's going to be built. And not only that, you can also go one step further, and here you can see how this layer will start from start to finish. So it starts with the dog bone, and we'll start with the second part. We'll do the infills, and then it will go to our main component, and then it will start with the support material, so on and so forth. So you can do this for every single layer, or you can simply hit play animation and it will automatically go. That's all I really have for the actual GrabCAD print. So let's go back to the PowerPoint and we'll go through a couple frequently asked questions. Okay, so let's go to some facts. Can I use material from my Dimension or other Fortis machines? No. The reason is the material cartridges have been completely redesigned and will not fit. Previously, the Dimension and Fortis machines had enclosed material cartridges, whereas the new machines for the F123s and F123s, they're actually open where you can see the spool of material, and the printer itself has an enclosement that you drop the spool in, feed it in, and close the enclosement. So no, you cannot use them. Do I have to use a GrabCAD print software? GrabCAD is the only software for the F123s and F123s. Can I record videos of my prints with the new camera? No. Unfortunately, the camera only records still shots. We're finding this is less of a demand in the field. People wanted the camera in the corner to make sure that their prints were successful, but with these machines, they're so reliable and so tough. Prints rarely fail, and I really do mean rarely, so it's not really a big issue anymore. So as you can see, here we are. How long will a print head last? Print heads will last approximately 1,500 hours. That's roughly 1 year of use. So one of our customers prints every single day, 24/7, and their print heads last them about 6 to 8 months. But customers who print less than that, their print heads will last about a year to 2 years, depending. Are the PLA heads different? Yes. PLA heads are in gray in color and can only be used for PLA, and the reason is it's different melting temperature as well as a different extrusion type. So thank you everybody for joining us. Thank you for bearing with me with my computer struggles, but I really appreciate you guys for joining, and I hope that you learned a little bit about the F123 printers. I'm very excited about them because I know they're going to make a big difference in the speed of printing, the cost of printing, and the reliability of printing. So thank you very much. If you have any more information or questions you'd like to pass on or ask, feel free to reach out to me. It's david.hayes@javelin-tech.com, and I'm here to answer questions for the next 10 minutes or so. So thank you very much, and have a great day.